4.5, prove trig identities. So by the end of the lesson, you should be able to use basic identities and ones that you've learned this year in this chapter to prove more complex trig identities. So let's go over last year's trig identities. One of the big ones was the Pythagorean identity, cos squared alpha plus sine squared alpha equals 1. Okay, you should definitely have that one memorized. Tan alpha equals sine alpha over cos alpha. Again, a very basic one that you used many times last year. All of your reciprocal identities from last year you should know, and you should be prepared to use them. Cotan alpha equals cos alpha over sine alpha is another one that comes up. It's related to, of course, this one, but you should be able to use that one as well. And these are the newbies. Compound angle formulas. You've used them already. You should be able to, at the very least, recognize that when you see something like this, sine alpha plus cos beta minus cos alpha sine beta, should twig you that you should be able to change something like that into one of the compound angle formulas. Or if you see something like this and you know that your right hand side or your left hand side of your identity does not have a compound angle, then you have to change it into something like this. Okay? Double angle identities. So these came up in your homework for 4.4. Sine 2 theta equals 2 sine theta cos theta. You should know that sine 2 theta does not equal 2 sine theta. Those are two different things. This is the sine of twice the angle theta. This is twice the sine of theta, which is the ratio for sine theta. Two completely different things. So I would strongly suggest you have this one memorized. I would also strongly suggest that you have at least the very first one memorized, cos 2 theta equals cos squared theta minus sine squared theta. The reason is that this one is very close to this one. So you should be able to recognize that one has a plus, one has a minus. They equal two, of course, very different things. So that one also should be on your radar. Okay, let's do a few examples. Okay, let's do the first example. Prove that cos pi by 2 minus x equals sine x. So what I've got on the left side is something fairly complicated. What I have on the right side is fairly uncomplicated. So I'm going to start with the left side. And we're going to say the left side is cos pi by 2 minus x. And we can see in our formula sheet that the cos of pi by 2 minus x is already an identity. It's an identity that says it's equal to sine x. But if we wanted to prove it, then what we have to do is use some other identity. So we're going to use the compound angle identity, and we're going to say that cos of pi by 2 times the cos of x plus the sine of pi by 2 times the sine of x is equal to the cos of pi by 2 minus x. Everybody sees that, right? This is the first angle, this is the second angle. We just apply the identity to each of those angles. It's not like distributive law where you're just multiplying cos by pi by 2 and cos by negative x. Okay? So then, now, cos of pi by 2, we have to go to our Cartesian plane, to our pi by 2 angle, which is here, and this is the ordered pair 0, 1. So we know that the cos of pi by 2 is 0 times cos x, plus the sine of pi by 2 is 1 times sine x, which is 0 plus sine x, which of course is just sine x, which is the right-hand side. Therefore, cos of pi by 2 minus x is equal to sine x is an identity. Okay, let's do the next one. prove that cosecant 2 theta equals cosecant theta over 2 cos theta. So again, we're thinking about which one's more complex, and I'm going to say that in this case, I would work with the left-hand side, even though it's only one trig function. It's still a complicated one because it's cosecant and because it is a double angle. So I would go ahead and choose the left-hand side. And then what I'm going to do is I'm going to try and change it. So I know that cosecant of any angle is equal to 1 over the sine of that angle. So this is going to be 1 over sine 2 theta. And I know that sine 2 theta, we have an identity for that. We know that 1 over sine 2 theta is equal to 1 over 2 sine theta cos theta. Which now I'm going to break this apart because I think it'll be easier for you to see what's happening here. So I'm going to write this because I'm looking at where I want to go. I can see that my bottom has to have 2 and cos theta. It can't have the sine theta. So I'm going to separate them out. I'm going to put 1 over 2 cos theta as one of the rational expressions. And I'm going to write 1 over sine theta. So we know our rules for multiplication tell us tops by tops, bottoms by bottoms. So if I multiply these out, I'm going to get back to where I was here. But in separating them out, it just helps you to see what you can do with this. I know that this is fine the way it is for now, and that 1 over sine theta is the equivalent of cosecant theta. And then when I multiply them back together, I get that cosecant theta times 1 is just cosecant theta over 2 cos theta, which is the right-hand side. Oopsie. So therefore, sorry, my pointer is missing. I'm trying to do this without the sort of the pointer, and it's really, really hard. Okay, so then my left side was cosecant 2 theta equals my right hand side, which is cosecant theta over 2 cos theta, is an identity. All right, let's keep on going. Okay, so we've got this big ugly one now, and I would say that both sides are pretty complicated, but the right hand side is less complicated. Yes, we could change cos squared x into something else, but you can see that right off the hop we could apply the compound angle identity to each of these, and that would kickstart things. So I think that's where we should go with this. So left side equals, just rewrite it out. Let's see, that shouldn't be a bracket, that should just be a cos x minus y. So now, let's apply that identity. So we know for the cos of 2 angles that are being added, it's the cos of the first times the cos of the second minus the sine of the first times the sine of the second. So that's the first thing. Now these things are being multiplied together, right? Bracket. Oopsie, that's not a bracket. They're just side by side. So I'm going to, again, put this one in a bracket then, and we're going to say the cos of x times the cos of y plus the sine of x sine y. And if you sit back and look at your handiwork, then really there's nothing you can do to simplify the individual terms, but this is 2 terms that are being multiplied together. So I would say this is very much like we could FOIL this out. And if you didn't notice that this looked an awful lot like a difference of squares, you could just go ahead and FOIL each term, right? And you would end up with 4 terms, and then you're just going to reduce it down. But I can see that this is the same as this, and I can see that this is the same as this. And so I think what I should be doing is just writing it as cos squared x cos squared y. So the first term squared minus the second term squared. That's what it simplifies down to. The middle terms will cancel each other out. Okay, so now that I've got that, I have to think about, let me look at what I'm trying to get to here. I've got some co-squared x's and some co-squared y's in my solution so far, but I don't have any signs over here, and I have some here. So I'm going to try and get rid of those signs. So what can I replace them with? Well, I know that sine squared x plus cos squared x equals 1. That's the Pythagorean identity. So if I isolate for sine squared x, that's going to equal, when I move the cos squared x over, 1 minus cos squared x. So that's what I'm going to replace sine squared x with. So it's going to be minus bracket 1 minus cos squared x. And I'm going to do the same thing. This is just going to be the equivalent, but with a cos squared y. Okay. Now I got a whole whack of coses. That's probably a good thing, because that's all I really have here, plus the 1 or minus the 1. So nothing I can really do here yet. Let's work on getting rid of these brackets. What about if I FOIL this? 1 times 1 is 1. 1 times negative cos squared y is a negative cos squared y. 1 times negative cos squared x is negative cos squared x. And the last one is positive cos squared x cos squared y. Now when I look under the brackets here at the terms that I've got from resulting from my foiling, I don't see any opportunity to simplify these down. So what I'm going to do is just get rid of the brackets. Sorry, that's a plus cos squared x. And then this is minus cos squared x cos squared y. All right, oopsie, no bracket. So once I've, oh goodness, sorry about that. Good enough. Okay, once I've got this, then I'm going to look at opportunities to simplify this. So let's see, I've got a cos squared x cos squared y, and I've got a minus cos squared x cos squared y. Well, I know for sure that I'm going to just be able to cancel those completely. That's good. And then when I look at what I'm left with, my fingers are crossed, whoopsie, that it's going to be what I need here. So let's see. I'm going to have minus 1 plus cos squared y plus cos squared x. Let's just manipulate that so that it looks more like our right hand side. So we know that we can move those terms around, and that's equal to our right side. Therefore, cos x plus y, did it again. Cos x minus y equals cos squared x plus cos squared y. Minus 1 is an identity. Don't forget, I will give you a mark for that. So please don't forget to put that conclusion in, even if you don't have the left side equal to the right side. Okay, foiling, a lot of foiling there, and canceling and using the compound angle formula. Okay. Oy, oy. Let's have a look at this. Definitely the left-hand side is more complicated. Now it's little itty-bitty cos x's and sine x's, but the thing is that I think, if we looked at the right-hand side and thought about, oh, how do I get it, build it up so that it's the left-hand side, it's harder to pull things kind of out of thin air to build something up with. It's easier to take something that that's fairly complex and simplify it. So I would definitely be looking at the left-hand side in this case. And because it's all these little cos thetas and sine thetas, there's really nothing you can do with the individual terms, but you can certainly, you can certainly combine these two expressions. So that's where I would be starting. I would be adding these because you want one single rational expression here, so you got to start combining things. So of course there's no common denominator here. Okay, so that means that the common denominator is just going to be the product of the two. No, yay. I don't know what happened there. Okay. So then, when I have to multiply this by cos theta plus sine theta, so what I end up with on the top is just cos theta plus sine theta all squared. I end up with two of them, right? Being multiplied. And then ditto for this one. So I'm just going to, again, put that in brackets, cos theta minus sine theta squared. Now be so careful. We cannot cancel here. We cannot cancel these cos theta minus sine thetas here and here because of the subtraction sign. Okay, we cannot cancel up and down here. No, 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 because of this plus and minus sign. You can only cancel things when they are factors of each other on the top and the bottom. Okay, so for example, 2 times 3 over 2, no problem. Cancel the 2's because these are just being multiplied. If I have 2 plus 3 over 2, I cannot cancel that. 2 plus 3 over 2 does not equal 3. So I need you to be, before you cancel, to be thinking very, very long and hard about whether you're algebraically allowed to do it. Okay, so I'm going to expand all of this out because I cannot cancel. I have no other choice. I don't have any cos squared theta plus sine squared theta. That would be nice because then I can make that 1. But I'm going to have to expand this out. There's nothing else to do. So cos squared theta, so it's the square of the first, the square of the last, and then 2 times the product of the 2. So with the sine. So plus 2 sine theta cos theta. I know to write it that way because I know that that means something. But if you wrote it as 2 cos theta sine theta, that's fine as long as you understand that you can switch the order of those because it's just multiplication. Is that my doorbell? Okay, I'm just going to pause. Okay, so I'm going to expand out this one now, and this is going to be cos squared theta minus 2 sine theta cos theta plus sine squared theta. All right, now we're cooking. Oh my goodness, I'm so sorry, guys. All over cos theta minus sine theta times cos theta plus sine theta. And as I've told you, you need to be keeping your eye on the prize, right? We need it to look like 2 tan 2 theta. Well, we're nowhere near that at this point. So we're just going to keep on going here and see if we can cancel some things and simplify. So we're going to leave that. Oh, sorry. Oh, guys, I'm sorry. I missed the last minus sine theta here when the doorbell rang. So this was cos squared theta plus 2 sine theta cos theta plus sine squared theta minus, and then we've got this one expanded out. My bad. Okay, so cos squared theta plus 2 sine theta cos theta plus sine squared theta. And then I'll just get rid of the brackets here, minus cos squared theta. Oh, let's not do that. Oh well. Let's do it. Plus 2 sine theta cos theta minus sine squared theta. There's many different ways you can do this, so we're going to deal with this. It's no big. Cos theta minus sine theta times cos theta plus sine theta. Okay, So let's see, what can we do with the numerator here? I've got a cos theta and I'll just use my red here. I can cancel that. And I can cancel that. And when I combine the two that are left, I end up with 4 sine theta cos theta. Okay. Over cos theta minus sine theta times cos theta plus sine theta. Now this one's complicated for sure. So what I want to do now, is keep my eye on the prize here. I need the top to be maybe a sine 2 theta and the bottom to be a cos 2 theta. So that would work out really nicely. But right now I can see where this could become sine 2 theta. I'm not seeing that yet. Or maybe you are, but if I expand out the bottom, so leave this for now. Remember, try and only do one step at a time. So if I FOIL this out, you end up with cos squared theta minus sine squared theta. Remember, this is like a difference of squares again. And if I continue to work on the denominator, I can see that is my identity. The cos of 2 theta equals cos squared theta minus sine squared theta. Remember? So I'm going to use that identity here, and so I'm going to call this cos 2 theta. And then if I really wanted to, I could write 2 times 2 sine theta cos theta, right? 2 times 2 over cos 2 theta. And I'm going to turn this into sine 2 theta. I know that identity well, and you should too. So that's 2 over the sine of 2 theta, the cos of 2 theta. And then sine 2 theta over cos 2 theta, we know, is tan 2 theta, which is equal to my right side. So therefore, what did I start with? Some big ugly thing, right? I'm not sure. Oh, heavens. Cos. Okay. So it was cos theta plus sine theta over cos theta minus sine theta. And then I think it was minus cos theta minus sine theta over cos theta plus sine theta is equal to 2 tan 2 theta is an identity. Okay, that was tricky, that one. There was a lot going on. It was definitely a level 4 identity, but yeah, it definitely is doable, obviously. Okay, I have given you an extra practice sheet, and I will try and post some of those solutions as I work through it and as time permits. Thanks for listening.